Hey there, I hope you've had a wonderful week and got caught up on all those Unreal Fest videos. If you're itching for more video content, our recent webinar on real-time ray tracing for architectural visualization is also available for viewing. Build Media showed how to set up and optimize a ray tracing pipeline for live navigation through a photoreal interior with NVIDIA Quadro RTX GPUs. Roughly 2 years later, after the release of Robo Recall on Oculus Rift, Drifter Entertainment was tasked with porting the game to the Oculus Quest. Despite more modest system specs, Robo Recall Unplugged plays identically to its Rift counterpart. The game features the same amount of enemies, physics, and spatial audio as the original. Drifter Entertainment was able to bring all of this over with just 7 people in 6 months. To shed light on how the team accomplished this, we interviewed technical director Matt Tonks. He outlines challenges the team had to overcome, elaborates on what optimizations netted the biggest performance gains, and shares Quest development tips. We have good news for current and aspiring Unreal developers. The demand for real-time 3D skills, especially those associated with using Unreal Engine, are becoming integral to many occupations across the economy. Burning Glass Technologies, a labor market analytics firm, found that the demand for Unreal Engine skills is growing faster than any other segment in real-time 3D, and those jobs are paying the highest salary premiums in all of 3D graphics. You can read the full report, Visualizing the Future, Demand for 3D Graphics and Real-Time 3D Across the Economy, or check out our summary for highlights. You may have noticed a few changes to the look of the Unreal documentation site. Along with changes to the visual style, we've made improvements to streamline the site, improve its reliability, and make pages load faster overall. A few tasks related to the migration are still in progress, so you may find some functionality not behaving quite the way it ought to. While we work through to update everything, please bring any odd behavior or any other feedback to our attention in the Documentation Feedback Forum. As fans of arena shooters and Portal, 1047 Games set to create a Halo-esque multiplayer game featuring Valve's innovative teleportation mechanic. What began as a college dorm prototype using the shooter game template evolved into an FPS that fundamentally alters the genre in a new, compelling way. Hear from their studio CEO and co-founder as he describes how they optimized gunplay to take advantage of portals, elaborates on how they design levels to facilitate tactical teleportation, and exclaims how they're eager to bring back the glory days of arena shooters with a new, modern twist. As we gear up for E3, we know many Unreal devs from around the world are preparing to showcase their projects on the industry's biggest stage, and we're proud to partner with Intel and NVIDIA yet again to host the Unreal E3 Awards. The awards provide an opportunity to recognize outstanding achievements across 5 distinct categories while rewarding teams with top-of-the-line hardware. Each team that takes home top honors in any category will be awarded an NVIDIA GeForce RTX 2080 Ti graphics card and an Intel i9-9900K processor brought to you by Intel's Game Dev program. Email us at e32019@unrealengine.com to let us know you'll be at the show. And now for our top weekly Karma earners. Many thanks to Everynone, Shadow River, Arlen, MR, Norlin, Indie Game Cove, T. Sumisaki, Nebula Games Inc., Augusto Mora, and Garner P57. They've helped their fellow devs on AnswerHub. Head on over, answer questions, and you too could see your name up here. All right, on to our spotlights of this week. First up is a Scandinavian interior using ray tracing with everything rendered in real time. In addition to this beauty, Pascal has many other stunning scenes, so be sure to give him a follow and see what else he's working on. Next up is Zira Survival, an action-focused looter-shooter designed from the ground up as a multiplayer open-world PvP-VE experience with a global gear stash. It's year 2022. When a prototype combat robot becomes self-aware, only you and competing mercenaries can end a war that humanity cannot afford to lose. And our final spotlight this week is Aluris, a swipe-your-own-adventure game where you explore an interconnected world by only swiping left or right. Raid dungeons, steal loot, repair broken carts, marry a rat. It's up to you. Thanks for tuning in for the Unreal Engine News and Community Spotlight.
Hello, everyone. Welcome to another episode of the Unreal Engine livestream. I'm your host, Victor Broden, and with me today, I am fortunate to have pipeline developer Aaron Carlisle and senior programmer Jamie Dale calling in from the UK. And we've listened to all of you. I have received several survey reports that said that Python in Unreal Engine, Python, we want to see Python. So, yeah, I'm super happy that you guys were able to come here, be able to do the stream. I think it's going to be there's a lot of good stuff that I don't think a lot of people know that you'll be showing us today. And so without much further ado, oh, actually, one thing first. We will be giving away keys to Zera Survival, which is a new game that was released. Well, I believe you saw it in the one of the spotlights there. Was it one of our spotlights? It was not. But we will be giving out Steam keys to all of you today. So keep an eye out for that in chat. And with that said, I think it's time to do some Python.
Sure.
Yeah, so please feel free to take over.
Absolutely. So before I start, I just kind of want to preface the stream with Jamie and I's goal for the stream isn't necessarily to show specific things that you can do in Python. We'll show a little bit, but I think our goal is to give people the tools to kind of hit the ground running. So hopefully by the end of the stream, even though you don't know the specific things that you can do in the engine, you have the tools to figure it out. So with that, let's go ahead and get started. I'm going to open up the Epic Games launcher. And we'll go ahead and create a brand new project. So we'll launch 422.
And yes, we need to update to the latest patch. I know y'all can see that. But we tested in 22.1, so we know everything works.
Yes.
So we're sticking with it.
So we'll do a new project. We'll have blank. We'll use the starter content, so we have some stuff that we can mess with. We'll call this Python live stream demo. Create project.
I'd say that's a pretty good project name. It's accurate.
Okay. So the first thing is when you're first starting to try and use Python, it is a plugin in the editor. So the first thing that you have to do to use it is enable the plugin. So you go to Edit, Plugin, you just type in Python. You'll enable it, and it'll ask you to restart. Just go ahead and restart the editor.
This is common when you set up a project. Like, oh, I forgot that plugin. I need this.
So now that it's open, I'm going to close the output log just in case nobody knows where it is. In order to run Python commands, you have to have the output log open. So you go to Window, Developer Tools, Output Log. And in the bottom left corner, you'll see this CMD. All you have to do is switch this to Python, and you're basically ready to start writing Python. So you could do print hello Unreal, and you're ready to go. So now that we're up and running, we can go ahead and dive into the Unreal Python libraries. To access it, the base namespace is Unreal, so you could just do import Unreal. So that gives you access to all of the modules for the Unreal library. Oh my goodness. A couple of useful things that you can do with the console that are pretty standard in a Python console is to run previous commands. You can simply press the up, and it'll show you all your previous commands. You can run them as you please. The other thing is for multi-line execution. So if you wanted to do that, you would do like 4x in range 10. You would hold shift and then hit enter, and that would give you a new line, and then you can tab in for x. So that's just some useful stuff. To dive more into the Unreal library, the easiest things that I've found to figuring out what you can do in the editor with Python is to use, obviously, the documentation. I'll go ahead and pull that up. if you go ahead and put this over here. If you just Google Unreal Python docs, you can pull up the documentation here. So this has everything that is exposed in Python. So if it's not here, the chances are it's probably not exposed in Python yet. But one of the hard things is figuring out what to look up. So there's a couple tools. The one that I find most useful when modifying assets is if you find a particular asset that you want to manipulate or find out what things are exposed on it that you can do, just find the asset that you want. So we could take this SM chair. If you right click and you go to copy reference, that's going to give you the game path to the asset. And then you can use, we just call this chair asset. And then you could do unreal.load asset. And then you just paste it. Get rid of the prefix. If you run this, and then you do unreal.log chair asset. This will give you the game path, and then obviously the class instance that is what this object is. So in this case, it's a static mesh. We could just copy this, go back to the docs, paste it here, and we have Unreal Static Mesh. And then in here, we can see all the properties, the members of the class. So this is very useful. It has all of the documentation that you would find in C++, just wrapped in a little bit more nicely for Python. So that's really cool. If you didn't want to use documentation, obviously you can use the built-in methods like help and dir. So if you do for attribute in dir chair asset, and then print. That will also give you everything that is exposed for that object, which is pretty useful. And then you could also run the help command. And that will give you pretty much the same thing that you see in the documentation. Just go ahead and scroll up so you can see. So if for whatever reason you didn't want to use the documentation, or you were just kind of in the zone trying to figure things out, those are very helpful tools for figuring things out. Also, there's a couple things that you might want to do with assets, like getting and setting properties on the asset. The easiest way to do this is to, you have the reference to the object that you want. So pretty much every...
Quick break.
Yeah,
because we need to show a bit more of the window, because we're actually not seeing what you're typing on the stream.
Okay.
So just a quick break while we try to adjust that. In the meantime, I'd like to verify, because I saw a couple of questions. We're only using Python to edit the editor, right? And
Yes,
to
yeah.
use it for different ways that we can import assets and sort of improve your pipeline and your workflow.
Yes. It's mainly for automation in the editor. Nothing is runtime.
Correct. Yeah. So just so that you all know that we're not using it at runtime for gameplay logic.
Good to go. Cool.
See, we're good to go. Is that better all?
So if we look at, if we go back to the documentation for a static mesh, we see all these properties. We could just choose one. Let's choose, we could do LOD for occluder mesh. We'll do this one. So if we wanted to query what that attribute is, or what that property is on the mesh, we would just do prop equals chair asset dot get editor property, and then we just supply it with the property that we want to query. Print prop. It's -1. So that's very useful. In the same way, we can also set property. we could just do value of 1. And then if we query it again, it's 1. So in every case that you want to set an editor property, you can do it this way. Some properties can be set in the traditional manner. So you could do chair asset dot lod for a occluder mesh equals, and then set it to whatever your value is. Can Jamie talk?
Yes, he should be on.
So I think I'll hand off just briefly to Jamie so he can explain why in some cases you can use the traditional property method versus using get and set editor property as an actual method.
Okay, so when you set attributes in Python, the things that are exposed to you to use for that are things that have been exposed as blueprint read only or blueprint read write. There's 2 reasons, therefore, you would want to not use that if you want to access properties that are not exposed to blueprints but have been exposed to the editor via edit anywhere and I think view anywhere or visible anywhere. Those are accessible to get and set editor property, but they are not exposed as attributes. The other reason you would want to use the functions rather than to set directly is the functions will invoke a post change notification, which will notify other things in the editor that you have changed this data. You'll actually see in the output log there, it says that it built a static mesh for the chair after Aaron set that property, and that was because there is a post change hook on that to rebuild the mesh. If you'd set it via the attribute, that wouldn't have happened. Nothing was notified in the editor. So you can basically think of set editor property as if you'd set the property from the details panel, whereas setting the attribute as if you had set it in code, like in C++ or Blueprints or Python. So those are the only 2 differences: difference in visibility and difference in setting behavior.
Awesome. Thank you, Jamie. So with that, I think the next step, obviously, now that you're in the console, you're running some commands, you're kind of figuring things out. You probably want to write code in a way that you can keep, rather than relying on the editor to keep your history. With that, the editor, when it launches, or when you enable the plugin and relaunch the editor, it does have places that it looks for when it's trying to find Python files that you can import into the editor. Basically, any content folder that has a Python folder, all of the scripts in there will be in the Python path. So in this case, the best way or the easiest way that I found to figure out what folders those are is to just simply use the sys module. So you could do import sys, and then so these are currently the folders that are in the Python path. One thing to note, not all of these folders actually exist. So if I were to take, say, take this one, and we do import os.start file, it's going to complain that it doesn't exist. We can remedy that very easily. We could just do os.makeDirs on that path. Oops. And then start file, and now it exists. One thing to note, though, with this, because they didn't initially exist when you started the editor, you actually can't put Python files in here and import them into the editor because it currently doesn't know that it exists. So like if I were to create a file in here, do a text document real quick. Just create a new folder, a new file. And
what software are you in now?
So this is Vim.
Oh, sorry, I was actually muted. I was asking which software you were in.
So this is Vim. I just chose it because it's kind of there's not a lot of bells and whistles. There's not a lot of noise with it. It's also like my default editor. But you can use whatever you want. You can use Sublime, PyCharm, Eclipse, whatever you want to do your Python development in. This is just what I like to use.
Cool.
So we have this Python file called Unreal Test. If we try and import it, it's going to complain. So the solution to this is just to simply restart the editor. And then it'll detect it the next time it comes in. Go to the Epic Games launcher. See if we can find it again.
Loading, and boom.
All right, so we'll go ahead and try and import that module again. And now it discovers it. So if we go back to this and we just write a simple function, and we could just do unreal.log. Hello, Unreal. Save that. Reload it. Import it again, and then do Unreal test.log. Was it? And now it's running the script that I wrote. So that is basically how you get started with enabling the plugin, starting to run some Python commands, where to put scripts. One thing that I did want to cover before I move on to actual examples is the init Unreal file. So the init Unreal file is basically a startup script. There's similar scripts for this, like in Max and Maya. Basically what it does is it just executes some code that you have in the script at the time that you start the editor. So if we create one, we could do init. Actually, we'll just do and we'll actually just oops. And we'll change the log level to warning so it's a little bit more clear when it launches. So I'm going to restart the editor again, and then hopefully when it launches, you'll see that it'll log hello Unreal in yellow. So let's go ahead and give that a shot. Close the editor. Relaunch the editor. Watch it load.
Yeah, which unfortunately y'all can't see.
So as you see, it logged out hello Unreal.
Nice.
So that's very useful. Obviously, if there were specific things that you wanted to launch, like a tool or a menu or whatever it might be, that would be the place to put it. So with that, I'm going to go ahead and move on to kind of some specific examples of just example code that highlights some of the useful things that you can do with Python. A lot of the stuff that I wrote was to basically cover things that might not be exactly obvious when you first start and would actually probably take some looking into. So I'm going to go ahead and open up, go to desktop real quick. Copy these two. And we'll go back to oops. And we'll just dump it into here. So this first one, put this on the left, put this on the right. So the stuff that I'll cover is importing assets. In this case, or in this example, I'm going to import a skeletal mesh. And then I'll go over how you would like regenerate logs, set metadata on an asset, get selected assets in the browser, and saving assets. So for this first example, we're going to do, I'll just actually go over it real quick. Basically how importing works is you create an import task, You set some properties on it, for example, like the file name, the destination path, destination name, whether or not you want to suppress the UI. And then you set the specific options for whatever type of mesh that you are importing. So the best way to figure out what things you can set is in the documentation. So if we look up this one, if you look in here, you can see everything that you could set on the actual import task itself. And then when you want to set the specific options based off of the type of asset that you're importing, you would look up FBX import UI. And this has all the things that you can set for specific asset types. Like, for example, in the skeletal mesh import data, it uses everything from this class that you could set as properties. So if we look this up for skeletal mesh, we can do all the stuff that's available here when we're doing the import. All the options that you don't actually set in code are basically, they just set to default when you run the import. So I'll go ahead and close this. We'll import asset automation, and then we'll satisfy some of the requirements, like the FBX path. I'm going to actually copy. I have this test asset, Drongo, from Paragon. We're going to go ahead and import this one. Put an R in front. So there's our FBX path. The game path, we'll go ahead and put it in game content. If I could type. And we'll just do Drongo. And then the asset name, we'll just call it Drongo. And now if we do asset automation dot import skeletal mesh, feed it the FBX path, the game path, and the asset name. Let's see here. Maybe I spelled game path wrong. Oh, I didn't set it to a variable. Did I do the same thing with asset name? I did. That's funny. Cool. All right, so now it's importing the asset with all of the specific options that we set. So if we go to our content browser, content, Drongo, and here is the skeletal mesh. So this is actually really cool. I mean, we were basically able to automate importing an asset with specific FBX settings or specific import settings, which is useful when you have artists or a lot of artists that might not know the specific settings, or they might forget something, so it just kind of reduces user error. So I'll move this over here. The next thing I want to show is regenerating the skeletal LODs. So right now there's only, let's see how many LODs. There's probably only one. Yep, so there's only one LOD on here. So we can also automate, actually I'll just close it. We can automate the LOD regeneration. So we could do, actually, I forgot to assign this to a, I'm just going to delete these real quick and then re-import it. And assign the result to a variable. So if I were to do print Drongo asset, it just gave me back, the method that I wrote gave me back the asset itself. So now that we can actually do stuff with it. So we could take the asset and do asset automation, regenerate skeletal mesh LODs. We'll feed it the Drongo asset and the number of LODs, so we'll just do 4. We'll go ahead and run that. So this is good. Basically, ran into our first error. I think this is a good opportunity to discuss how Python is exposed in the engine. Basically, anything that is exposed in blueprints is exposed in Python. The cool thing about this is you can extend the Python library as much as you want, and it'll just automatically work, which is really cool. But one of the gotchas is if there are plugins that have blueprint exposure that you want in Python, you have to make sure that those plugins are actually loaded. So in this case, the reason why I couldn't find the method that I was trying to run is because there's a specific plugin that isn't loaded. So if we go to edit, plugins. Also, I wanted to say it's not obvious right now which plugin is the dependency, but I think Jamie is working on a way to make that a little bit more clear in the documentation. So we'll go ahead and enable editor scripting utilities. This is basically the plugin that it was missing, which will require restart. I'll save the assets.
And now that you've imported the asset, you no longer have to reference the actual file path. You can just reference the name, and Python will know which one to reference.
Yeah.
Okay.
Yeah. Yes. So since I had to restart, I have to get that asset back so I can do stuff on it. So I'll just do like I did when I first started. I'll copy the reference. I'll do Drongo asset equals unreal.load asset. Paste. Get rid of the prefix. And now we have our Drongo asset back. Cool. So now let's see if we can regenerate those LODs. Cool. So now it's regenerating the LODs. Once it's done, we'll go ahead and check it out real quick. I probably could have chosen an asset that didn't have so much topology. Okay, so if we go in here, I'll just move this back over here. And if we look at the LODs, there's 4 now. So that's pretty awesome. So it just kind of demonstrates that along with the automation of importing an asset and its options, you can do additional stuff after the fact, which is very useful. Especially just when you want your artists to focus on like art, obviously, not the clickety-click stuff that they have to do to get started to do their art. So this is cool. The other thing I wanted to show is metadata, setting metadata on assets. This isn't blatantly clear on how to do, kind of like with importing or with the regenerating of the LODs. So I'll go ahead and demonstrate that real quick. We'll just go ahead and set just a generic metadata tag on the Drongo asset. So we'll do set metadata tags on asset. We'll give it the Drongo asset. And we'll just say Python and give it a value of live demo. So that went ahead and stamped the asset with the metadata, and then if we want to get it back, we'll just do git feed it the tag that we want. And oops, actually. And now we have the tag that we stamped the node with. This is very useful if you want to make like dependency connections with assets, or if you want to stamp assets with frame rate or time range or whatever things that you want to arbitrarily set on an asset. This is very useful for. The other thing that I imagine that will come up a lot is you want to do an operation on selected assets in the browser. In this case, I'm using the Unreal.global editor utility base. The caveat with using this one is that it will only give you the selection from the main browser. It won't give you a selection from any of the other browsers. But with that said, we'll go ahead and show that real quick. So if we select all of our assets here, and we just type asset automation, get selected assets, and then we can print those out. And now we have our selection. It just gives us references to the objects themselves, which is really cool. Now we can do stuff on it. The last thing that I kind of wanted to show as a specific thing is how to save assets. Since we already have a list of assets, we could just go ahead and run the save method on those assets themselves. So if we do asset automation dot save assets, and we give it the selected assets, and just run that. Cool. Actually, this is another good thing with an error. It says attribute error, array object has no attribute, get full name. So when you initially see what it printed back, it looks like a normal list, but actually what this returned was an Unreal array. We know this if we just do print type selected assets. It says type array. So basically we just need to convert this to a list so that we can access it or do list type stuff with Python. So we'll just actually do selected assets equals and then we'll run that again. Cool. So it saved all of our assets. So pretty useful. I think it is important to note that like even though things, I think this happens with every SDK that you are working with, whether it's like Maya, Max, or Houdini, or whatever it is. Whenever there's an implementation that wraps the C++ SDK, you're going to find things like this that aren't blatantly obvious. I think if you just work through it with troubleshooting, like with figuring out what the type is, using dir help, the documentation always helps. I think things will just be a lot easier. So with that, I think the other thing that I wanted to show, one of my coworkers, James McNatten, wrote some example code for Python exposure and sequencer. So I'll go ahead and show that real quick. Actually, I'll just navigate it to here. Cool. So basically what this script is doing is it's generating a bunch of cube actors in the scene, and then it's going to animate them, and then pull up the sequence, and then you can see it play. So I think what I'll do is window, world outliner. I'm just going to delete all the geometry in here so that we could see it better. So we'll import so we've ran into the same problem that we had before. where there is a method that I'm trying to use that is exposed only in a plugin. So we'll go ahead and enable the correct plugin for that. In this case, since we're dealing with sequencer, we just need to enable the sequencer scripting plugin. Yes, and restart. Yeah, we could save.
Which versions of Python are supported?
That's a good question. So currently, I think Jamie will talk a little bit more about this, but Unreal doesn't really care what version.
Okay.
It supports 2.7 and 3. The binary version of the engine is shipped with 2.7. But Jamie will go over how you can point it to like Python 3 if you want.
Awesome.
Yeah. So we'll go ahead and try and run that script again. Cool. So we have this scene here with a bunch of cubes. Sequencer opened. I'll just expand this a little bit so we can see. And if we push play, you can see that the cubes are moving around. I think this is a really cool example because it shows that you can do Python stuff not just with the editor or with the assets in like the browser, but you can also modify levels. You can spawn actors. You can modify actors, and you could also do stuff in sequencer, which is really cool. The last example that I wanted to show is just a, let me see if I can find it real quick. On the desktop. So this is just a example script that shows a bunch of cubes that I've randomly created in random spots within a threshold, and I'm basically serializing out all of the actor data, and I'm bringing it back into like Maya. And it's going to show that like if I make an update in Unreal, that update will propagate to Maya. So I'll go ahead and play this real quick so that you can see. So what it's using is Maya's referencing system. So I'm just taking all the actors and then using them to propagate back into Maya with, I think it just has one single source asset. I randomize the blocks, and then see if it runs. Yep, and then I update it in Maya. I think the reason why I wanted to show this was because it just demonstrates that having Python exposed in the engine kind of opens doors in other realms, like with the operating system, with different applications. It just streamlines the way that you can automate things in your pipeline. So I think with that, we can go ahead and pass off to Jamie. Jamie's going to cover some more of the advanced engineering stuff on like how Python is exposed, how you can expose your own stuff to Python, and yeah.
Yeah. Thank you. That's great. Everyone's excited.
Absolutely. I'm going to go ahead and close down.
Okay.
Yeah, we're gonna have Jamie control our computer here. So
The silly thing is Jamie can't actually see his Alt-Tab screen, so I'm going to try and make it as easy as possible as I can so that he can play a little bit of a memory game. Let's make sure that...
I appreciate it.
Cool. There you go, Jamie.
it's all yours.
Thank you. Okay, so as Aaron has mentioned, we have the Unreal module, which contains everything that's been exposed to Python. And the question you might now have is, okay, well, how do I put my own stuff in there? I've got custom things I've written for my game, assets that I want to manipulate in Python, or I want to do something in the editor, and I found some functionality that isn't available to scripting, but I want it to be. And I will just say, given the breadth of features in the editor, it is entirely feasible for you to find something in the editor that we haven't exposed yet, and you might want to wrap that up. So I'm going to demonstrate how to do that. But just quickly first, I wanted to explain what the Unreal module actually is. This isn't strictly required knowledge, but it does explain some of its quirks and its limitations. So the Unreal module is an in-memory module for Python, created in C++ and managed by our Python script plugin. There is no on-disk version of the Unrail module itself, so you can't call the Python reload function on it, and if you try, you will get an error. And you also can't import it into any other Python interpreters. That one comes up most often when people want to add the Unrail module to their IDE for autocomplete. They're like, where do I point my IDE to get the Unrail autocomplete working? And unfortunately, while you can't import the actual module itself, we do have a solution for IDE autocomplete by generating a stub file, which I will demonstrate in a bit. And I will also just say that while the Unrail module, as you see it and as you use it, it looks very monolithic, it's actually composed of all of the public symbols of many, many submodules. So we generate a Python module for every UE4 module that is defined by the Unrail build tool. So every module that exists in the engine, everything that exists in your project, and everything that exists in any plugins can all have Python. There's two kinds of modules that we generate there. One is always called _unreal_x, where x is the name of your module, and that's what contains all of the reflection generated code. And you can also optionally, for any module, create an unreal_x.py file on one of the paths known to the editor. And if you do that, you can put some custom Python script in there that you can expose to the Unrail module. And we'll cover that later as well. So getting into exposing C++ to Python, if you have a poke around in our Python plugin, you might see we do have some hand-wrapped Python. And we kind of don't want to add much more of that than we already have. We have some for our most primitive types that control how to marshal data between Unrail and Python, but we prefer for most of the functionality to be exposed via reflection, simply because this lets us keep parity between things that are exposed to Python and things that are exposed to editor utilities. And we are very keen that you should be able to script the editor using either of those solutions and have the same functionality available to you. So in terms of actually exposing, if you've ever exposed something to Blueprints, this should be very, very familiar to you because we use basically the same syntax as Blueprints with some extra bits of metadata that you might want to apply for Python. So we support Blueprint read write for property visibility and Blueprint read only. We support Blueprint callable and Blueprint pure for function visibility. We support Blueprint getters and setters if you want to add a accessor function for a property. And we even support like native make and native break. If you want to create a custom constructor for your struct, you can do that. There are a couple of things that we don't support that Blueprints use. One is Blueprint internal use only, which is a tag usually put on functions that exist only to be an implementation detail of a custom Blueprint node. And we also don't support custom thunk functions because those require Blueprint bytecode, which Python doesn't have. So that said, let's hop into a little example to start with. If I can, there we go, okay. So this is a very basic example. This is the sort of thing that you would do if you had an object that you'd written for your game, you have control over it. So this could also be an engine object if you are working on a source build of the engine and you're comfortable changing it. But in this situation, I've created an object here. It has this extra macro markup that we have. This is what the Unrail header tool parses and generates reflection data using. So in this specific example, I have two functions that have been added. One of them is marked as Blueprint callable, which will expose it to Blueprints, and it will also expose it to Python now. And the other is marked Blueprint pure, which will also, do the same thing. In terms of Python, there is no distinction between a callable and a pure function. This only has any impact to Blueprints. You should probably bear it in mind when you're doing it. Even if you're only exposing things for Python, then you might at some point want to use them in an edit utility. So it's kind of important that you get these correct. We've had some cases where lots of functions were accidentally marked as pure where they shouldn't have been. And then the same thing for properties. So we flag a property with the uProperty keyword, and then this will be readable and writable from Python and Blueprints. So it's marked as Blueprint read write. The actual implementation of these functions are quite small. So my basic function just checks whether the value it is given is greater than 0, and my pure function just returns to me the value of the pure test property. I'll also just note that all of the comments that you see in here, these are like written using our standard Doxygen format that you'll see all throughout the engine. UHG parses these as well, and we take them into Python, and that is what we use to generate the doc strings for the help that Aaron showed you before. So if I hop back into the editor and I have a look. So if I do help and then Unreal my demo object, that was not a Python command.
So quiet when there's no clicking.
I know it's a Mac keyboard as well, so there's no. Okay, I don't need the viewport. So this is showing you all of the help functionality that's available for that object. So here you can see the stuff that I've added to it. So here's my function. This tells you it takes an argument. This tells you its return type. You can see, as I mentioned, the comment here has been extracted and converted into a docstring syntax for Python. So there's my two functions. You can also see my property, if I can actually scroll to that. There we go. My property here. And this gives you certain pieces of information for properties. So it tells you its type, and it tells you whether it's read-only or read-write. So with that, I'll also just note that you might notice that the names here are not the same as the names that were in C++. The C++ names were camel-cased. These have been converted into kind of a PEP8 standard for Python. And also some of the values, like the input parameter for this function in C++ was called inValue. We've removed certain pieces of prefixes that we don't really want in Python. So we very commonly use in and out as prefixes for function parameters. We very commonly use b as a prefix for a bool. All of those are removed when generating the names for Python. Also, any of the prefixes on the types themselves, so like u for an object, a for an actor, f for structs, and e for enums, all of those are also stripped. So with that, I can actually make an instance of this object. Like that. And if I print the result of calling my function, passing in 10, and bear in mind this function, it returns true if the value is greater than 0. So that should return me true, as I would expect. And if I pass in 0, it returns me false, which is what I would expect. So I can do the same thing with my pure function. Which just returns me the value of my pure test property, which I expose it to blueprints and to Python. So it's available to me as an attribute. So I can just do this to set it, and then call the function again. As you can see, it now prints 10, which is exactly what I would expect. So this is a very, very simple example. This is what you would do if you had control of the object itself. But it's also quite feasible that you will have an engine object that you want to expose or an object that you can't change. So in that situation, we're going to use this as an example. And we're going to pretend, for the sake of this example, that my demo struct is an engine type that you can't change, and that we want to expose its lock count property, which isn't exposed to scripting, to Python. So the way to do that would be to create a function library. All of our function libraries inherit from a blueprint function library base, which just sets up some context information for blueprints. These have to contain static functions. You can't create instances of them either. So this is very, very similar to the previous example in terms of syntax. I have view function, I have them marked up for blueprint exposure. In this case, they are static because they have to be static. Something that might be unusual if you've not seen it before is uparemref. That exists in this case because for reflection generated code, a const reference is treated as an input. but a non-const reference by default will be treated as an output. So if you have a parameter that you want to be an input and an output reference, you have to mark it as uparams_ref. For Python, that literally generates a function that takes in the type by value and returns it by value. It would be exactly the same as if this was passing in by value and this was returning by value. Blueprints show that slightly differently. They show a diamond reference pin. You'll see both of those methods used throughout the engine, depending on how old the code is. So to demonstrate that more effectively, I could pop back to the editor and show you the help syntax for this object. So yeah, you can see here with lock struct, the function in Python returns a demo struct, and it takes a demo struct as a parameter, which is different to the C++ signature that you saw, but it just explains how the conversion happens. So yeah, it actually mutates and returns your copy. So we can now use that. So I'll need an instance of my struct, which was, what was that called? My demo struct, of course. So now I have an instance of my struct. So now I can use my library to query and manipulate that struct. So I can check to see whether the struct has been locked, passing in it as an instance. And no, the struct is not currently locked, which is what I would expect. So we can go ahead and lock it. And because this function returns a copy of the struct, we have to reassign ourselves. Library. And now if we check to see whether the struct is locked, it is true, correct. Okay, so this is working, but you might be thinking, okay, well, using a library, it's not very, kind of more like C than it is Python. So is there anything we can do to make that nicer, make this feel like more of a native object? And the answer is yes. So we have a bit of extra metadata that we've put onto these functions called script method. Script method for Python will add this as an extension method of the first parameter in the function signature. And this can be used for both structs and for objects. You can also provide an optional name to this metadata. So in this case, because the function in the library isn't really desirable in terms of a name for a method, I've renamed them to remove the struct part of their name. And you can see this if I do help on my struct. You can actually see here the member functions. And you'll note that these signatures have been transformed. So the library versions of these took a parameter and returned a parameter, but these versions, they don't take any arguments, they don't return any arguments, because internally in the Python glue that gets transformed so that the static function is called with the self argument, and then the self argument is assigned to the result. So now if I do is locked on my struct itself, it is locked because we previously locked that instance, and this is just calling exactly the same function as the library. So we can also unlock it. And then check to see if it's locked, and it's no longer locked. So what happens if I unlock it again? Okay, I get an error. That's interesting. So in C++, when you encounter an exceptional situation in Unreal, you might be tempted to solve that using a check. Our goal for the scripting is that you shouldn't use things like that in the script layer, because that will crash the editor if such a case occurs. what you probably want to do instead is feedback that information to your user so that they can correct their mistake. And you can do that using this frame Kismet execution message. If you set one of these, then these get forwarded through to Python as an exception. Unfortunately, they're just a generic exception. You can't control the type. But they do at least provide you a way to inform that something has gone wrong. Obviously, because this isn't a check and it isn't stopping the execution, you are responsible for making sure that the error case doesn't cause bad behavior. Because if I just checked this count, raised this error, and then still decremented the count, I would still end up in a position where my lock count was negative, which isn't something that I wanted to happen. So that covers like how you would wrap something for Python. But you might be thinking, okay, so this is a lock type. I have a lock function, I have an unlock function. It would be really, really nice if I could use that with the with keyword in Python. And unfortunately, you can't do that via reflection. But as I alluded to earlier, you can create Python files for UE4 modules. And in there, you can put extra bits of Python that you would like to go into the Unreal module. So you can create these for any module as defined by UBT. They all, as I mentioned, have the name Unreal _ and then the module name. They can go in any path that the editor understands, but it kind of makes sense to put them in a logical place. So in this case, this is for my project, so I put it in my project's content Python folder. If I was working on a plugin, I might want to put it in my plugins content Python folder so that it's nicely modular. I will say if you are going to put Python in plugins, then you have to also make sure that in your plugin settings, you have turned on content. So if I open this up real quick. So one important thing to note is if you create one of these Python files, you are responsible for importing all of the public symbols from the reflection generated module. So you have to have this line or equivalent for your module at the top of the file. If you don't do this, all of this will be available, but any of the stuff that was generated via reflection won't be in the Unreal module. So it's very important that you remember to do this. I will also point out that at this point in time, because these modules are imported and their symbols imported into the Unreal module to build it, you can't import and use the Unreal module itself here, but you can use anything from your submodule. So in this case, we've imported our native symbols. We have created a little Python object here, which has the enter and the exit keywords, which is required to work with the with keyword. This takes an instance, which in our case will be our struct. When we enter, we call lock, and when we exit, we call unlock. So if I go back to the editor again, and use this example. So I'm checking my struct to see whether it's locked. I am creating an instance of the type that I just showed you in the Python file, which is inside the Unreal namespace. It's been imported into the Unreal namespace. Passing in my struct, checking to see whether my struct is locked. And then I am checking to see whether my struct has been unlocked when this with statement ended. So if I run that, you can see I get false, true, false, which is exactly what I would expect to see. So that covers the basics of exposing things to Python, exposing C++ to Python via reflection, and also adding custom Python to the Unreal module. I would just like to speak very briefly about performance considerations of doing this. So obviously, every time you call in to access a property from Python or you call a function from Python, you do pay the cost of marshalling data from Python to C++ and from C++ back to Python. So if you're going to be passing large amounts of data like large arrays, large structs, and you're going to be doing that repeatedly, it could potentially cause you performance issues. Ideally, you would probably want to avoid doing that. If you can pass large amounts of data into C++ and C++ does most of the heavy lifting and returns you the result, then that would be most ideal. If you can't do that, then one alternative would be to put your data inside a UObject and pass the object around, because that's very cheap. It's basically copying around a pointer. So you're not paying the cost of copying your array or your struct every time you call a function. It's just passing a pointer to that data around. one thing to be aware of, obviously, if you do that, objects are mutable. So every time you call a function with that object, the data that you had beforehand isn't necessarily the same as the data you will have a reference to when you finished calling the function. I'd just also like to cover, so I mentioned the script method metadata. We have a few other pieces of metadata that you might want to take advantage of for exposing C++ to Python. We have one called script operator, which is how you can put a variety of operators on structs, R math types, which you can find in Kismet Math Library. Make extensive use of those. We also have script constant, which allows you to create a static function that returns a type and make it as if it were a constant attribute on a Python object. It's not, strictly speaking, a constant insofar as it's generated once. It's still a function, so every time you access that attribute, it calls the function and returns you that object. But that was the safest way to avoid you being able to change data on a constant within a Python script. And there's also a piece of metadata called script name. That is essentially the Python version of display name. So you can use that if you have a function you want to expose to Python, but you don't like the name that it was given in C++ and you want to give it a different name. The syntax for that is the same as script method. And if you take a look in pytest.h and .cpp, there are a number of examples in there that use these features. And there's also test_wrappertypes.py, which demonstrates using those test cases. So I mentioned previously that although you can't import the Unreal module into an IDE for autocomplete, that we have a solution for that, which involves generating a stub file. So in order to get the stub file generated, you need to go into your project settings, go to the Python setting, and then in here, you need to turn on developer mode. Developer mode does two things. One, it generates the stub file that you can use, and two, it turns on deprecation warnings. Python has deprecation warnings turned off by default, but as we continue to work on UE4 and we continue to add and remove features, we may deprecate things over time. So at some point, you'll definitely want to test your scripts with developer mode on to see whether you're using older features that you should consider replacing with newer features. So when this is on for the stub file, inside your project, inside its intermediate folder, there will be this Python stub folder, which will contain this file called unreal.py. This is generated every time the editor starts, and it is generated with your exact set of available code. So if you have added game code, this will be in the unreal.py file. If you have turned on plugins, it will be in there. If you've turned off plugins that were available to the engine, then they won't be in there. So the list in here may be different to the list you see in our documentation, but this is an accurate representation of what is available in your specific project. I will note that this file is quite large. It's like almost 10 meg by default, and certain IDEs will require you to increase the size of your parsing file limit. I believe PyCharm defaults to 2 meg. I think VS Code is about the same. So you might have to increase them in order to get the autocomplete working, but you can absolutely put this file somewhere that your IDE can access, and then when you do import Unreal, it will import this stub file, which doesn't have any functionality in it. It's just all of the signatures of all of the functions with all of the doc strings, stubbed out with all of the type information to give your IDE a best chance as possible of showing you what is available in Unreal. And then one last thing, if I can find Visual Studio again. There we go. Aaron mentioned that we ship with Python 2.7. We do that because it is currently the VFX standard version of Python. When the VFX standard moves forward to Python 3, which they will be doing within the next year, we will move forward as well. Our plugin as it stands supports both Python 2.7 and Python 3. And if you want, you can change the version of Python that you use if you want to be more forward-facing and start working on Python 3 right now. However, you can't do that in a binary build. So if you're using a build from our launcher, unfortunately, you are stuck with Python 2.7 right now. simply because the Python plugin itself needs to be recompiled. We link to the CPython library, so we have to recompile the plugin. But if you are using a source build, the simplest way of replacing the version of Python that you're using is just to set an environment variable called uepythondir, and set that to point to any Python installation that you have, and then when you rebuild the plugin, we will use that version of Python rather than our version of Python. The downside of that approach is it's not very portable because it ends up baking a path into your build to a local Python SDK. So if you gave this to someone else, unless they had the same version of Python in the same place, potentially Python would fail to load, or it would find the wrong version of Python and then it would crash. So it's very quick, it's very easy, but it's not very portable. If you wanted to create a more portable solution, then the best way to do that would essentially be to replace the version of Python that we ship with the engine with your own version. So these are stored inside the third-party directory, the binaries third-party Python folder, and the source third-party Python folder. And you would go in there and you would replace the SDK that we ship with the engine with your own, rebuild, and then we'd start using that version. And because this is inside the engine directory, we convert this path into a nice portable path. So you don't have to worry about it changing between machines. Although you do have to make sure that if you're going to replace the Python SDK, you have to use the 64-bit version of Python because the editor is a 64-bit application. So that covers everything I was going to talk about with regards to exposing to Python and modifying Python. I just wanted to quickly mention some upcoming features that will be coming here. So we have added for 4.23 a feature called remote execution. What this lets you do is find any editor instances that are running on your local machine and execute Python on them. You have to turn this feature on. It's not on by default. You can enable it in the Python project settings. But the interesting thing about that is the script that does the remote execution will run in any Python interpreter. So we have internally used this inside Maya to find an editor instance that's running on someone's machine and invoke an asset import like Aaron showed you earlier. You might want to do that rather than use the commandlet-based approach that people have been using so far if you are in a situation where multiple editors are going to be running on the same computer, because when the editor loads an asset, it keeps a write lock on the file. So if you spawned another commandlet to do an asset import and another editor had already loaded that asset, you might find that you can't save the asset afterwards. So remote execution allows you to work around that limitation by, instead of creating a new instance, connecting to an existing instance and having it do the work instead. I know we've previously had streams on editor utility widgets, and we are continuing to make Python more usable from editor utility widgets. So for 4.23, we've done some work to add some functions to let you call Python from editor utilities. This is slightly nicer than the previously recommended way of doing it, which was to use the exit console command and prefix it with py. These allow you to not have to do the prefix, and they also support multiple lines of Python and everything that the Python interpreter would support via the output log. Going forward, I would like to have a better version of that where we have a custom node that you can add inputs to as properties and add outputs to as properties, and then you provide us with a small amount of Python script that basically implements a function, and we do all of the data marshalling for you. So it's seamless. But I don't think I'm going to get that finished in time for 4.23, so that will hopefully come with 4.24. The other thing we are actively working on is menu extensibility, which is also hopefully going to be coming for 4.24. This will replace our existing menu extensibility with a nice unified system that works with C++ and blueprints and Python. And this will give you the ability to extend menus and toolbars in the editor without having to use C++. So you'll be able to just use Python to add toolbar buttons and add menu entries. And this will also give you various pieces of context information. So Aaron mentioned that the way to get the selection from the content browser right now, it will only give you the selection for the primary content browser, which means if you have a second content browser open, there's no way to do that. What you might want to do in that situation when we do have menu extensibility is hook into the content browser context menu, and that will give you the context of the selection set. So you're able to work with it like that. And we hope that more things that are context specific like that end up getting moved into menus. And that covers everything that I want to talk about.
Nice. Thanks a lot, Jamie. There's quite a bit to take in there. I'm really glad we were able to walk through all this. Are you guys ready for some questions?
Yeah,
Because
do it.
I have 2 full pages of them, so
Oh,
we'll see how
nice.
many we can go through. Possibly, maybe, I will share all of them with you later, and you can go through them and see if there's something like that you might want to fill in on the forum that's a little bit tricky to answer here today. Let's start with, when was Python implemented? How long? People weren't even aware that it's existed in the engine. They were wondering when it was implemented.
When was the first release, Jamie?
419, I think.
Okay, so it's been out for a little bit. And you did cover that you could use any of the Python versions. Someone mentioned in chat that you were deprecating Python 2.
Well, I think the goal is to switch to Python 3 when the VFX platform switches to Python 3.
Okay.
Python 2 itself is deprecated. It will end of life by 2020.
Yeah.
Does Python have more stuff exposed than blueprints with editor scripting utilities enabled?
It shouldn't do. There are a few things that are exposed to Python via hand wrapping, as I mentioned, but those are mostly for convenience or because we hadn't exposed them via reflection at that point in time. Our goal is that Python and Edge utilities be very have parity in features.
There were some talk about possibly if you were able, I don't know if you can, but if you could show an example of how to call Python from an editor utility widget.
I could show you that if I had a 423 editor.
Okay.
Because, in fact, if you go to the live stream that Lauren did for edit utilities, she does mention how to call Python from a utility widget right now, which is to use the exec console command. That only works properly in 422 because in older versions it required a world, which we weren't giving it. But for 423, there'll be a much nicer way of doing that.
All right, sounds good. So there's some more things coming in 423 that makes that a little easier. Okay, that's good to know. Is it possible to create BSP brushes from Python?
I have no idea.
I mean, I would suppose so. I don't think you currently can.
Okay.
But I definitely think that if somebody wanted to expose that, they could.
Can you run a UE4 Python script headless from system console without the Unreal editor opening up?
So you can use a commandlet to do to run a Python script headless. That's currently the only way. One thing that I would like to note with that, though, is the headless version of the engine has a limited amount of modules that are loaded. So not everything that you might want exposed will be exposed because it hasn't loaded those libraries yet. But yeah, you can absolutely run a Python script headless or Unreal headless and run a Python script.
Nice. Let's see. Oh, we did get a question if Python scripts can be published on the marketplace, and we reached out to the marketplace team because we haven't actually received that question or someone trying to release it on the marketplace. And the answer we got from them was that this is not set in stone because it's all new, but they wanted to chime in with we would probably allow it as long as it's in Unreal Engine plugin format and that it's wrapped in Unreal Engine C++, so that it makes it through our build pipeline. Was the answer to that? And that would be great, right? People can make scripts for some automated things, and then you really release it on the marketplace, and
That'd be really cool.
possibly us puny designers
You could probably just create a content-only plugin and add Python scripts to it.
Okay. Yeah.
Because if you had every plugin can have a content/Python folder. So.
Mm-hmm. Yeah, we'll definitely follow up on that afterwards because that sounds pretty interesting to me. Is it possible to use pip in editor to add additional packages?
So you can't really use pip in the editor, but you can use pip from command line and then you could just point your third-party packages to like a Python folder in the engine build, so that those libraries are available in the Python path, and you can access them in the console.
Nice. Let's see here. There's quite a few. Can you access, let's say, UAsset data files from there? I think the person is referring to Python, or sort of the output log in Unreal, or the console. Can you access, let's say, UAsset data files from there to load a configuration to apply to?
I guess would need to know what they mean by configuration.
Yeah, I don't actually have. That was way early in the stream, so it's a little tricky for me to go back and check that. We'll see if someone wants to clarify that one. We'll get back to it. Keep an eye on chat here. So when you were working on the when you were automating the import of the skeletal mesh, they were wondering what's considered default on the import settings. Is it the most recently used, or is it engine default?
Actually, I'm not actually 100% sure if the defaults when running Python are like their base defaults or whatever your last import settings were. I imagine it's doing the same thing as whatever the editor would do manually, but I think Jamie might probably know better.
In terms of what Python does, it just calls a new object. So there will be the defaults from the class default object, not the last run of the import.
So it's whatever the defaults are in the documentation.
Yes.
Cool.
Which I don't think we actually list the values for. I think we just tell you that they're available. We should probably add the defaults to the documentation.
Well, I don't know. I'll make sure you get all the questions and then you can go over them. And there were several questions, and I know we mentioned it, but I want to repeat it again. Is there a simple way to add Python scripts buttons to the standard Unreal UI? Yes, since 4.22 you can use editor utility widgets, and they allow you to customize the editor interface using UMG. And you can call Python scripts and functions from editor utility widgets. Let's see. Can you set up the importer settings codes so it happens on every imported assets instead of explicitly calling it on one?
Yeah, absolutely. Actually, I'll go ahead and show something real quick to make that a little bit more clear. Oops. So where it's doing the actual import, it's using this method called import asset tasks. This is actually, you can supply it a list of tasks. So you can structure this however you want. You can have a class that kind of extends out with subclasses that do specific things based off of the asset type. Handle it pretty much however you want. Queue up a bunch of different tasks with specific options, and then run the import asset tasks on those import task objects, and it'll just automate that stuff for you. So to answer that, it's yes, absolutely.
It's awesome. Let's see here. Let's get back to where I was in the list. Could this be used to automate repetitive tasks such as selecting/painting weight maps when importing landscapes and/or tiled landscapes?
Possibly. I don't actually know if any of that stuff is exposed, but with all the information that Jamie just shared, it's pretty much anything that you would want to do in Python you can expose. You just kind of have to expose it.
There were a few questions about example scripts available somewhere. Does any of them exist?
There is a couple, I think, on the documentation site. And I think in the future, with like the scripts that we've done in the stream, we'll just continue to update those docs because they also give context And our documentation is really, or our documentation team is really good, so they can format it in a nicer way. And I think that would be the best way to go. So, yeah, I don't. Do we have a link to those docs?
They should be available from if you go to the Python documentation on the documentation website, there is a link down the side for examples of something, and they give you examples of how to do it in both Blueprints and Python. As Aaron said, there's 2 right now, but if you have things that you frequently bump into that you would like some kind of cookbook style example of how to do, then let us know and we'll try and work with the documentation team to get them added.
Yeah, feel free to add more questions and comments in the announcement post on the forum. I can go ahead and link that once we're done with the questions here. Can you use Python to spawn actors on painted vertices on another mesh, for example? Can Python access that data?
I would say I keep having to go to say that you kind of have to expose it. You can spawn actors all day. All day. You can query data about actors. If on the actor that data is available and is exposed to query, then there's no reason why you couldn't query that data and then position your actor based off of that data. If it's not exposed, it just means that it needs to be exposed.
Can I use Python to write a script to associate ftext objects with string table IDs?
I think that's more of a Jamie question.
Yeah, that comes into localization as well, which is also my ballpark. No, I don't. Not in Unreal. One way to do that might be to create a CSV string table and then import the CSV file as an asset.
Let's see. Is it possible to have Python code that plays the game in the editor and take control after the play session is over? I had to create a watchdog in C++ to make it work.
I don't know. I suppose the actual playing maybe, but nothing like none of the Python code is runtime. It cannot be done during the time that the game is playing. So I suppose it's possible you could trigger the editor through Python or through like Py through Python and then query it when it's done. I'm not really sure how, but I imagine that should be possible.
And then a couple of specific questions here, but is the IPython script plugin on Python initialized callback working? I need to do some setup after the Python plugin is initialized, but I could not get it to work.
It should be working. Might be called very early. Let me check.
I'll let you follow up on that, Jamie, well, maybe I should let you finish that before I ask the next question in case it's one that you need to answer. Let's see, I'm going to watch chat real quick. See if there were any follow-up or more details on some of the questions we had earlier. I don't see any. Yeah, if we responded to one of your questions and we didn't face the question right or we didn't understand it, feel free to add details further in chat when you hear it come up. Let's see, I'll show a question and hopefully you can answer it, Aaron. Is there an easy way to generate Python docs only for custom code that we create on our project instead of creating the docs for the whole code base?
So it's like what Jamie said. Once you enable that Python stub, every time you recompile it, it will take an account of the additional stuff that you've added. You can correct me if I'm wrong, but
I can just answer that real quick. Yes, there are flags you can pass to the docgen commandlet. One of them is include project. So if you only pass include project and you don't pass any of the engine and the enterprise flags, then you will only get your project code exported in the documentation.
Cool.
Yeah, that's great. Let's see, there was another question about custom UI, which is editor utility widgets if you're just tuning in. When using threading in the Python scripts, the output console does not show anything until the thread is finished. is there any way to run a thread and still get the output in the editor?
Well, I mean, I guess it depends on how they've set up their thread. Because I imagine if you just had a logging handle, you would be able to output that data back to Unreal through your thread. But it would kind of depend on how they have their thread set up.
Okay.
I can confirm the initialized delegate is called when Python is initialized, so it should be working. If it isn't working, then feel free to give us a specific example repro, and I'll take a look at it.
Yeah, he said it was using a static function. Yeah, please, you can follow up on the forums, and Amazing Jamie here will take a look at it. Can you please show how to use the step file for non-programmers?
The stub file. So I don't know if we have a good way to demonstrate that, but like Jamie said, the stub file is pretty large. So if you're trying to use it in whatever IDE you want, Eclipse, VS Code, or PyCharm or whatever, I think as long as the stub file is a part of a path that your IDE recognizes as a module, and you've set your parsing file limit to be more than 10 megs, then I don't see any reason why it shouldn't just work. Unless Jamie has an example.
I don't, I'm afraid. I have used it myself. I've used it in PyCharm. I've used it in VS Code, but I don't have either of those available to show.
Yeah. But I think it should be pretty straightforward. Just drop it in, make sure your IDE recognizes it, and then it treats it like any other module.
Nice. We're actually up to the last question here. Let's see if you want to throw any others into chat. Will PySide or any other Qt framework will be available with Unreal in the next versions?
Do you want to answer that, Jamie?
So our official solution for creating UIs from Python in the editor is to use edit utility widgets to do that, and then we're going to improve the situation of calling into Python from there. You can use PySide if you install it with pip, but it's not something that we will officially support at this point in time.
Nice. I think that was all the questions I have for you guys.
Sweet.
Yeah. Anything else you want to mention? Anything you felt last minute is like, this would be amazing if I told everyone about?
No, I just hope that it was enough information for people to kind of hit the ground running.
Yeah, definitely should be able to get started. And as you mentioned previously of line 2, there are so many specific things that you can do that it's almost impossible to sort of show them all or showcase them, right?
Yeah.
Because as from my little understanding of hanging out with you guys here and seeing what you're working with, it seems that with Python you can pretty much script anything that's related to your assets and files in Unreal Engine, and so it's sort of more up to you and your project or your team or your pipeline what you want to do, and at that point you can sort of dig into the specifics of what the actual script needs to look like. We'll definitely try to follow up with a link to a couple of examples. There were a couple of questions of that. We unfortunately didn't prepare that for the stream, but we'll see what we can dig up for you guys. And as always, remember to check out our user groups that we have all around the world. If you're interested in learning more about Unreal Engine, who works with it, what they do, or even networking or meeting some folks in the games industry who've used Unreal professionally, make sure you check out our user groups page. Follow us on social media, all the traditional things that streamers and YouTubers want you to do. We want you to do that as well, obviously, because it means that you'll see when we go live. It means that you can see all of our updates and all the amazing videos that we've uploaded. I do want to make another shout out for all the videos for Unreal Fest Europe. I am slowly going through them, and there is so much useful information in there. It's all extremely relevant, up to date. I specifically recommend Shord's Blueprints in Depth talk. Even if you work with Blueprints for years and years, which I have, and other people, he's showing us some things in there that I had no idea you could do, like automating, doing automation tests for your code in Blueprints. And so which is just like absolutely amazing for a non-programmer like myself. Being able to automate, checking that everything you just refactored or changed is still working would be absolutely amazing. And I only thought you were able to do that in C++. So there's some amazing tidbits in there. He also goes over a couple of the things about like using like where tick is an engine, because it's not only the tick event, and yeah, it's just a whole lot of good stuff in there. And so I really recommend to watch them, or try to find time to watch them, because I think there's like 50 videos from all the talks we did there, which is pretty amazing. If you like us to showcase your project during our community spotlight, please go ahead and send us an email at community@unrealengine.com if you would like to just hit us up. If you'd like to have more people watch it, please feel free to post it on our released or work in progress parts of the forum. We frequently check those, and we often pick our spotlights from the sections. ArtStation links are good too. Depends what you're working on. And we have the countdown video at the beginning of our stream. If you would like, it's another way for you to showcase your project to the world. If you would like for us to showcase your video, go ahead and record half an hour of development, and then go ahead and fast forward that up to 5 minutes and send it to community@unrealengine.com with your logo, so that we can make sure that we brand it appropriately. And as always, special thanks to all of you coming in here watching. Thanks to Aaron and Jamie and Jamie, what time is it for you right now? It's pretty late, isn't it?
It's 20 to 9.
20 to 9. 20 to 9. Yeah. I think everyone is really happy that you were both able to take the time to come out here and teach us some of the amazing things that resides within your brains. Being able to show us how we can make our work better and easier. And that's pretty much what automation does, right? It improves your pipeline, some repetitive tasks that you usually do over and over and over, or like you mentioned earlier, preventing yourself and others on your team to make simple mistakes that can take a long time to track down or debug, or being a part of your game that's so infrequently tested or played, because it's supposed to just be normal, right? And you had a special mesh or something that you imported for just that thing, and you forgot to check import collision or something, right? And
for me, I feel like it's the automation and pipeline is all about getting artists to focus on their art, and not having to worry about all of the other stuff that isn't their art. The more time they spend working on their art, the more cool stuff they get to make.
That's awesome, yeah. If I was an artist, I would certainly appreciate that. I do appreciate that, because, programmers do the same thing with blueprints, right? And making sure that you can't plug the wrong data type into, you can't call the wrong things. And that definitely helps, not only when you're starting out, but to just teach you about data types, but it's also, you'll frequently try. It's like, why isn't it working? Oh, okay, I'm dumb. I didn't I didn't set the data type to be the class that I was trying to call a function on. All right, with all of that said, I think it's time to say goodbye for this week. Next week, we actually have Shord, which he did a Blueprint in Depth talk. He's actually going to be here in our studio. He's one of our European evangelists. He's actually the lead for our European evangelist. He will be here together with Juan Canada, and they will be, I think I named the talk, How to Get Started with Ray Tracing. And so they're going to walk us through how to get started with ray tracing, and hopefully we can pick their brains a little bit about the nitty-gritty about it as well, and not only the beginning. Awesome. Thank you guys so much for coming out.
Yeah,
it's been a pleasure. We learned a lot. And to everyone out there, have a great day, and we'll see you next week. Bye-bye.